Good morning, sixth graders. Today we are going to be talking about condensation. Okay, so yesterday we talked about evaporation, which is the change in state from a liquid into a gas. Recall that when we heat up a liquid, the molecules move rapidly and they become further spaced apart. And as they continue to move apart, they lose their attraction for each other, and one will eventually go flying off. Okay, and turn into water vapor. Now, if we have a volume of water vapor with all of those molecules really widely spaced, and we cool that gas down, what do you suppose is going to happen to these molecules that are widely spaced if they cool down? They huddle, right? They start to huddle back together. And that's what we're studying today. We're going to study something called condensation, where a liquid can change from a gas state back into a liquid. So it is the opposite of what we were studying with evaporation. Now I've started out, I'm going to make this big screen so you can see. I started out with 2 cups of ice water. Okay, this cup of ice water is exposed to the air around it. And this cup of ice water is sealed in a Ziploc bag. And the reason I set these up this way is so that you could see the difference in the amount of condensation that is occurring on this glass as opposed to the cup that's in the bag. Okay, if I take a paper towel, and all I have is white paper towel, so I don't know if you'll be able to see this very well, but if I take a paper towel and I wipe the cup, you will see that it is wet. Okay, it gets a little bit wet. That is all the condensation on the outside of this cup. If I take this cup out of here and I wipe the edge of it, you'll see that there is no water at all. This one is dry. If I leave this one out longer, it will develop condensation. In fact, it already is, just from sitting out here for that 30 seconds or so. You can actually see it developing right before your eyes. Okay, so why would a cup with ice water in it exposed to the air have more condensation on it than a cup that was sealed off from the air in this bag? Okay, think about that. Think about why that may be. Okay, let me put this back in here and put that aside. Another experiment that I want to do today to show you is I'm going to put some hot water into 2 cups here. 2 cups. Okay. This has some funkiness on it from past labs. All right, so I'll put some warm water into both of these cups, and then I'm going to quickly put, actually I'll just start with 1 cup. Quickly put the top on top of here. We're just going to watch and see what happens. What do you notice about what's happening inside this cup? We've got warm water. And usually warm water, every time I've poured warm water in all of these labs, it's pretty steamy, right? And so we might describe this as the cup is getting steamy. But what is actually happening? These water molecules down here are moving really fast. And they're flying out of the water. They're changing from a liquid into a gas. And because I've trapped them inside here, they have nowhere to go but spin around inside this cup up here. It's kind of like a chimney. They're spinning around up here. Now, the air around here is cooler than the warm water down here. Okay, so if we open up this cup and we wipe the inside of this cup, it is really wet with condensation, really wet. There's a lot of moisture in there. You can actually see where I wiped it off on the cup, right? Okay, so all of these water molecules were so widely spaced that they flew out of a liquid and they became a gas, but then when it entered into this cooler air surrounding here, those molecules condensed again, or they huddled up again and turned back into water, sticking to each other and sticking to the side of this cup. So let's talk about how cooling can affect that process. Okay, so we'll take this off. I'm going to pour this water back into the beaker to warm it back up. So we have two equally heated cups. Okay. Pour warm water into here and cap it. And pour warm water into here and cap it. But now this time I'm going to put some ice cubes up here on the top of one of them. We are going to see if we notice anything different happening here. We still have condensation happening on this side, for sure, for sure. Water molecules are flying out of a liquid and becoming a gas. They are cooling because the air up here is a little cooler than this hot water. And those water molecules are huddling back up and condensing on the side of the cup. When we look over here, the same thing is happening. And I don't know if you can see this on the computer, but I can tell from here that the rate at which that is happening is much more rapid. Okay, the condensation is thicker on this cup. It happened much more quickly, it became thicker, and if I take a paper towel and I wipe the inside of the cup, it is definitely going to be wetter on the inside of this cup than this cup. And the only difference here, this is the same temperature water, right? The only difference is that I have added these ice cubes up on top. So think about what that is doing to the surrounding air. Think about that, what that is doing to the air inside this top cup. Okay? And what does that have to do? What does cooling this cup have to do with the rate at which water is condensing? Think about that for a second. Okay, and one last thing. Move this one out of the way. Actually, I'll just pour that back into my beaker. Very, very wet on the inside. Very, very wet. How wet that is. You can see how much condensation was inside there. All right, so the next one that I'm going to do, I want you to think about this one. We're going to put hot water back in here. Okay, this time I am going to add a little bit of food coloring to this water. We know that that warm water will mix that up for us. I don't even need to get a spoon in there. It doesn't even need a spoon to mix it. The molecules are going to mix it for me. Okay, put a dry cup here. I'm going to put this on top, and I want you to predict what will happen to the condensation. Do you think this red will follow the molecules up in evaporation and be present in those water molecules when they condense on the side of the cup? What do you think? To give you a little bit of a hint, we get salt that we use at our kitchen table. Salt actually is a naturally occurring element, and we can harvest salt. Humans can go and actually harvest it from salt water. Okay, so if you think of places like the Great Salt Lake in Utah, that water evaporates, just like water evaporates out of our rivers and streams and lakes and oceans. But what is left behind are these big salt deposits. Okay, so the water evaporates and it leaves the mineral behind, and we can then go in and harvest that salt bed. We can actually do that by human means too, and we do. We actually can get fresh water for areas of the world that don't have a lot of fresh water to use. We can speed up the process of evaporation with ocean water for them. And so we kind of in a human way, we heat up that water, the water evaporates and it takes the salt out, right? That water is evaporating, it's condensing into a container and it leaves the salt behind. All right, so that is one way that we actually do get fresh water to some areas in the world that don't have it. Okay, and the same is true with this. We've got this red water down here. The red water molecules are evaporating and they're condensing on the inside of the cup. But when we wipe the inside of the cup, we might expect it to be a little bit pink, but it is not. It is wet and clear. So evaporation and condensation, my point with this little lab is that it is a way of purifying stuff. We can take chemicals and elements out of water by forcing evaporation and condensation in some sort of a way. Because solids and even things that are in solution in water don't evaporate with the water itself. Okay? Otherwise, we would have really, really salty rain, right? Because the oceans have so much water, and so much water evaporates out of our oceans every day, and then it would enter into the water cycle, and we would be really, really salty every time it rained. And that would be a really big mess. So thank goodness it doesn't. Let me show you just a couple little animations before I sign off here. This one here. Okay, so we've got our cup right here of warm water. You see these molecules here, they've left the water, they've gone into the gas state, and after time goes by, those water molecules have cooled down from the surrounding air, and they are huddling back together. The attraction is back, and they glom onto each other, and that's why we get little water drops, okay? The same thing happens in our atmosphere. Okay, so it says energy from the sun speeds evaporation of water from the ocean and from water on the land. Cooler temperatures in the upper atmosphere. So water evaporates, it enters the upper atmosphere, and it cools down. They condense into tiny droplets which form clouds. When the clouds become saturated, it rains, and the water cycle continues. So evaporation and condensation are two really big parts of our water cycle and are very important to life as we know it. Alrighty, well, what you've got today is another Google form with some lab questions on it. See if I can find where that is. Here it is. So I'll have that posted. You're just going to walk through, doing a little bit of reading, watching some animations of some of the things that I just did. You might be able to see what's happening a little better in these animations, answering the questions, and we will make this due on Tuesday of next week. Okay, so you're getting this on Wednesday. Tomorrow we'll just have a little bit of a wrap-up day after our Zoom meeting, and this lab won't be due until Tuesday of next week when you return to school. Okay? I will talk to you soon.